Hello everyone. In this short video, we're going to learn how to calculate the expected value without perfect information, or in short form, EVwoPI. So in order to calculate EVwoPI in this situation, we are given a payoff table, and we're told that that payoff table is profit in millions, and it is always important to pay attention whether the situation you're dealing with is dealing with profit or with cost. That will be absolutely critical going forward with the question. So in this example, we have three decision alternatives, D1, D2, and D3, and two states of nature. We're given the payoffs associated with each of those possibilities, but we're only given one of the states of nature. And hopefully we understand by now that if there are only two states of nature, we really only do need to be given one of them, because all of the states of nature combined always have to add up to 1, or 100% of the possible outcomes. So if we have a probability for state of nature 1 of 0.8, then state of nature 2 would have to be 0.2. With that, we now have everything we need in order to calculate the expected value of each of these decision alternatives, and that's exactly what we're going to have to do. We are going to have to separately calculate the expected value for each decision alternative, and then go ahead and choose which of those is the best expected value based on our profit or cost scenario. So beginning with the expected value of D1, what we need in order to make this calculation are the probabilities for each state of nature, and in this case with only two, we have them both, 0.8 and 0.2, and the payoffs associated with each possible outcome of D1, which we also have as an $8 million profit under an S1 state of nature and a $7 million profit under an S2 state of nature. Well, to calculate the expected value, we simply take each of those payoffs, multiply it by its associated state of nature, and then add them together. Or our S1 probability of 0.8 times the S1 payoff of $8 million, and the probability of state of nature 2, 0.2, times its payoff of $7 million. We simply do the multiplication, add those two together, and we get an expected value of decision 1 to be 7.8, or specifically, because profit is in millions in this situation, a $7,800,000 payoff. We would do that for each and every one of our decision alternatives. So for D2 and D3 for this scenario, D2 in exactly the same way, 0.8 times 14 plus 0.2 times 5. Finish that off, and we end up with an expected value of 12.2 million. And doing it for our last decision alternative, D3, dealing with our multiplication and addition, ending up with an expected value of 14.2 million. Now that we've calculated the expected value for each and every decision alternative, what we need to do now is to choose which of those is ideal based on this situation that we're dealing with. Well, again, because we are dealing with profit we always want the maximum profit possible. Obviously, if it was cost, we would want the minimum cost possible. Well, if I look at the values that we just calculated, expected values of 7.8 million, 12.2 million, and 14.2 million, the best of those is the 14.2. Therefore, my expected value without perfect information, or EVwoPI, would be considered to be $14,200,000. I could have also done this with the use of a tree diagram. Now, I won't go through how to create the tree diagram. If you're looking for that, there is another video that will explain how to create a tree diagram. But if I were to look at the tree diagram that I have already created for this scenario, to create this tree diagram, I used the online web application that I've made available to you. And what we should see is the exact same answer that we had doing it individually by the formula method. Our final decision, without perfect information, found at our first decision node in this scenario of $14,200,000. I really want to caution you with a couple of things though. When I make my decision tree, this final decision This decision that's on the leftmost side of my decision tree will not necessarily always be the expected value without perfect information. As we get into more complex decision trees and we start to add sample information, this might not necessarily be the place that I will find that. And I will go into more detail with those more complex trees as we get into them later. But in this situation, in this very basic situation, in this tree, that is where I would find it. And the other warning I give is we got to really be careful with the different notation. EVwoPI, which we just calculated here, EVwoPI, which is something that we're going to learn to calculate in a later video, or EVPI. They all sound very similar, but they are slightly different things. Thank you very much, and I hope this short video clears up any question you have about calculating the expected value without perfect information.